Hello classmates and anybody else out there watching who's studying anatomy. This week we're studying the anatomy of the ear. And since we're not dissecting on a body and we're using a model, I thought I'd make you a video so you had something to reference when you're studying at home later on. So the ear is divided up into three parts: the external ear, the middle ear, and the inner ear. So we're going to start with the external ear. So we're going to call the earlobe the lobule. This outer ridge here is going to be the helix, and this inner ridge here is going to be the antihelix. This portion of the antihelix is going to be called the scaphoid fossa, scaphoid like scaffolding, or the crura of the antihelix. So crura comes from the same root as crutch, so it's the leg of the antihelix. So this ridge right here, closest to your face, is going to be called the tragus, and this opposite ridge is going to be called the antitragus. So the fossa here behind them, the indentation in your ear, that's going to be called the concha, and that leads us here into the external acoustic meatus. So we're going to follow the external meatus, acoustic meatus, all the way back until it hits our eardrum, which will be right here. And we're now going to call the eardrum the tympanic membrane. Okay, so now we're going to examine the middle ear. So we disassemble the model like this, and then the middle ear comes off. So the middle ear is the area between the tympanic membrane and the membranes on the other side where the vibration will be transmitted through. So we're going to have three ossicles in here that are going to transmit the vibration. So I like to use the memory trick that I made up, MIS popsicle, to remember the ossicles. So popsicle stands for ossicle, and MIS gives you the ossicles in the order. So malleus, M, incus, I, stapes, S. So this here is our tympanic membrane, and so the biggest part right here, this is the malleus, and malleus means mallet or hammer, so I like to recognize it because it has this process coming off of it, which makes it look like a hammer you could bang down. So that's connected to the membrane here. It's going to receive vibration from the outside through the external acoustic meatus, transfer that to the middle ossicle, the incus, and transfer that to the final ossicle, the stapes. Now the stapes has this process here that looks like a stirrup for a horse. So this stirrup here is going to actually be on the oval window so that we can transmit our vibration from the outside to the inside. Another feature I'd like to point out on the model is that this pink area is called the epitympanic recess. So epi means upon or over, so this is the tympanic membrane, so it's the recess above the tympanic area, the epitympanic recess. So now we're going to look at the deep side of the middle ear. So this bump right here, this is the promontory, and it's where we find the tympanic plexus. So I like to think of the tympanic plexus as the TP plexus, T for tympanic nerve, which is a branch of cranial nerve 9, and P for lesser petrosal nerve, which joins it here. We also have two windows here. This one, the oval window, which articulates with the base of the stapes, and this one is the round window. And I remember that on our model as O for open, so the oval window is the open window. Now we're going to move on to the internal ear, which is encapsulated in bone by the otic capsule. And inside the otic capsule is the bony labyrinth with the three structures we're familiar with: the vestibule, the semicircular canals, and the cochlea, which is shell-shaped. So first we're going to look at the semicircular canals, and you can notice there's three of them. We have to learn to tell them apart. So there's an anterior, posterior, and lateral. And we know that anterior and posterior are opposite words, two sides of the same coin. So those are the two that are going to be sharing a connection here to the vestibule, and then that's the opposite side from where they have their ampulla over here. So we know that the lateral canal is the one that does not share a connection to the vestibule. So these semicircular canals contain semicircular ducts, which is represented by this plastic pipe. And you can think of it as a canal is an enormous thing. The Panama Canal has ships, whereas a duct in your house just carries air, so a duct is smaller than a canal. So inside the semicircular duct is endolymph, and then outside the semicircular duct here, in this space that's right here, is the perilymph, and then outside of that is the canal itself. And finally, we're going to look at the cochlea. The cochlea is the shell-shaped portion here, and it has an inflow and an outflow, but they're from the same tube. So it's one tube that comes in here, curves around, and comes out the other side. The inflow is the scala vestibuli, and the outflow is the scala tympani. And the way I remember that is that the ear's end goal is hearing. So tympani is a kind of sound, so scala tympani is the outflow valve. In the center, there's a blind duct, so a dead end, and that's going to be called the cochlear duct. And then over here, this is the innervation for the ear. So this is cranial nerve 8, or the vestibular cochlear nerve. and the portion going to the cochlea is the cochlear nerve, and the portion going to the vestibule is the vestibular nerve. And finally, we want to be able to ID the vasculature on our model. So the internal jugular vein and the internal carotid artery, as well as this tube here. So I like to call this tube the FAR-TIM tube when I'm studying. And it stands for the pharyngotympanic tube, or the auditory tube. And it joins the middle ear to the nasopharynx.